Well, g'day and welcome back to the shed. And this is part 4, unbelievably, of this Columbus Model 90. And well, so far, if you've watched the other parts, you'll realise that we have got it going on medium wave anyway. Shortwave is still profoundly deaf, but we will get there, I hope. It's taken quite a lot of effort from mostly other people to get this going, from David Tipton winding the coil, Ron supplying the transformer, and a lot of head scratching on my part, but we'll get there. So this time I'm going to try and see if we can get shortwave to work. It's going to probably be a matter of circuit tracing, finding out what's going on there and why it isn't going, and it shouldn't be too hard because medium wave is working. So there's only certain parts of the circuit that can be faulty, if that's the case, I guess. Anyway, on with the show. Let's see what we can do. So I guess we start from the beginning, and the beginning of course is the aerial. It gets switched to either one of these aerial coils. So I guess we can start with that, make sure that's happening. Now this blue wire here is the aerial. It runs along the chassis around here and out the aerial wire here. So it appears to be switched to, I guess these are the two aerial coils down here, so it'll be switched. There's one wire goes to this coil and one wire goes to this coil. So let's just check that and see that if there's continuity through to them for a start. So I'll connect one side of the meter to the ground, just check that it's zeroed. It's as good as it gets. So just looking at this, we'll put it on broadcast and see what we've got there. We've got some, but I think we're probably looking through the coil or something there. Put it on shortwave. Yep. So it is switching the shortwave coil in. At least I presume this first one is a shortwave coil. We'll have a look at the other one. Yeah, that's 0 arms on broadcast. On shortwave, yep, we're looking through a coil. Now, the other side of both those coils go to ground, so we will be looking through one coil to ground and back up to the other one. So that makes sense. We're just seeing the two coils in series there when they're switched out. The other side of this switch apparently switches this bank of trimmers in sequentially to the grid of the 6K7. Now this green wire here goes through and attaches to the grid cap of the 6K7. So I guess if I put my clip lead on it and we'll just see what happens. It's a busy afternoon at the airport. We've got planes coming over every 30 seconds or something, it seems like. Okay, so we're on broadcast. I'm pretty sure that will be the broadcast one. Okay, so at this side we have. So that's switched in at the moment to the grid. Without it in, we're looking through something, a coil I guess. Now, that's in the shortwave position. That's the 0 arms. Put it back to broadcast, medium wave. We're looking through a coil, so it looks like that part of it is working. I don't know about these, but I'll turn the switch around sequentially. Yep, that one comes in, goes out at the next click. That one comes in, goes out at the next click. And this one should come in on the last click. Yep. So these trimmers are all being sequentially switched across the grid of the 6K7, which is the RF amp. So that all seems to be working. Okay, so everything seems connected here. We've got these two coils being switched in, and we have these capacitors being switched into the grid here. They also have to connect to the secondaries of these coil, or the secondary of this coil, through to there. Alright, perhaps I better check that. Now these also have to connect to the tuning gang, so we should have the other side of the secondary of the aerial coil and the tuning gang all connected to the grid. So I've got this clip here on the tuning gang wire, it just goes through the chassis there, it's a plain wire, and this is the grid. So we're on broadcast band now, and well, we know that works anyway, that's connected to the tuning gang. Yep, shortwave it still is. Now interestingly, on these band spread bands, the tuning gang is switched out of circuit, the first RF stage anyway. I presume they just use the second stage, the RF stage, to tune band spread, because there's it is switched out, and I checked the schematic, there's no connection to the tuning gang on those other bands. That's the first tuning gang. So that's good, that's connected, that's connected. Now we're looking at the secondary of this coil, and that's that one there, that's connected and off on shortwave, so that one must be the broadcast coil. Same with this one, that's connected on shortwave, and on medium wave it's not, we're just looking through a coil there or something. Okay, so next I guess we'll look at this setup here, and we've got the plate of the 6K7 being switched through one or the other of these coils, and also a similar bunch of trim caps and capacitors being switched in here. We also have this 4 mic ground, which I think is always in circuit. I should have pointed out before, this says wave change switch is shown in broadcast position and moves counterclockwise direction for short wave. So we're looking at these switches rotating this way. So I guess we need to check this. Firstly, I'll check the plate of the 6K7 gets switched to these two coils. So the plate of the 6K7 is allegedly on pin 3, so 1, 2, 3, it will be this one. So I'll just attach that there. Now that wire, come on, stay on. Okay, there we go. Now that plate wire goes up to the switch here, I think. Is that it? Yep, that's it. Now it has to be switched to one or the other of those coils. That goes to that yellow wire there, and I'm not sure what else. We'll try this one. That's not it. Okay, so on short wave it's connected to this coil, and on broadcast it should be connected to one of these, not that one. Unfortunately these are down in this container. I can't see where the secondary comes out, but that's the broadcast side anyway, so we know it works. Okay, so just looking at this, this is the B plus line along here, and it goes to the bottom of both of these coils. So essentially this switch is switching B plus via these coils to the plate of the 6K7. So it can, I guess, check the continuity of that, but I could also check that this 6K7 is getting plate voltage under all conditions. Okay, so we're looking now from the filtered B plus, the B2 plus, to the plate of the 6K7, which is on pin 3, and we have continuity. Now that's on the broadcast band, and we're looking through a coil to it. You would expect the broadcast band to have a higher resistance, DC resistance. It'll have more turns on it, I guess. Putting it onto the shortwave band, and we have much less resistance, less than an ohm, through to the plate of the 6K7 from B+. Okay, so I've established that there's continuity through this part of the circuit through to the B+ rail, and that that's being switched properly through to the plate of the 6K7. So that's happening. The next thing to look at, I guess, is this side of it, and we want to make sure that now these things turn anti-clockwise. So As this rotates onto shortwave, this contact will be coming into contact with there, and that will switch the top of this coil through here to the grid of the 6J8. At least that's the way I think it works. So I just want to make sure that that's actually happening and that this is being switched through to the grid of the 6J8. That will be the trimmer. Also, we have to make sure that it's being connected to the tuning gang, of course. Now, the second part of this coil, the shortwave coil, comes out here, and the other side goes up to this trimmer. So if we look from there across to the trimmer, we should see through the coil, and being a shortwave coil, yeah, it's got very little resistance there. But looking at the coil, I can barely see any windings on it. I can see a fairly thick wire going down there. So I wouldn't expect an awful lot of resistance in that. Now that goes across to the switch here, and that should be switched through. This is the grid of the 6J8. So that's the grid lead, goes up through the chassis here. Now put it on broadcast. We're seeing through a coil there. Put it onto shortwave, and yeah, look, that appears to be being switched through okay. So we have continuity all the way through this. That doesn't mean that there isn't a dud capacitor in here somewhere. But the third thing we need to check, I suppose, is whether the oscillator's running. And I assumed that it was, because otherwise we wouldn't be, we'd be getting noise but no tuning signal, and we're getting nothing at all. Nevertheless, I think we need to check the oscillator, see if it's running. Alright, so let's have a look at the oscillator, and I've hooked up a clip to the oscillator plate here through a 0.1 cap to the scope, just to block any DC going through there. And I guess there's nothing but to turn it on. I've got it on medium wave at the moment. Let's just see what we get as it warms up. It's going up and down. There we go. Oh, so there's the oscillator on medium wave, and we can probably see it changing as we tune across the dial. Oh, there we've got a station there. It's losing trigger, but that's alright, we can do that. And there it is going up as we move across the dial.
Is the soundtrack to my life. Am I just a middle-aged man in a woman's body?
So, switching to short wave. No oscillator. Nothing at all. Oh, there's something there. Just, it moves as I tune it. There we go. Okay, so I've got a little bit of shortwave oscillator happening there. Nothing like the amplitude that we had on medium wave though, so I think that might have something to do with our problem. We're getting quite sensitive here. I'll put the time base up so there we can see it. And tuning across, yes, it's running. Now it's towards the higher frequency end. Go down towards the low frequency end where it was dropping out and see if I can see what's happening there. We're getting nothing there. Okay, so I thought I'd try tuning it. I've got it on maximum volume on the first shortwave band, and we are getting a little bit of sound here as I tune across the band. That's almost reception there, but not quite. Yeah, so nothing intelligible, but it is too early for shortwave reception anyway. But that is very, very weak. I've got that on full volume, I've got the outside aerial hooked up, and that's all we're getting. I would expect a lot more from a radio like this, so there's something not right here. I am really struggling to get my head around this schematic. Starting with this switch here, this is the oscillator circuit here. This one will be the broadcast band or medium wave oscillator coil. This will be the shortwave oscillator. And looking at this switch here, the schematic is quite unclear, but I think that arrow is not supposed to be contacting this ring here. You can see a bit of a lug going there, which goes nowhere. But the switch is shown in the medium wave position, and shortwave, for the shortwave it rotates anti-clockwise, so we can expect this lug on here to travel around to here and then perhaps contact this. It can't be connected all the time, because here's the secondary of the broadcast oscillator coil. It's on grounded that side. It will go around there, up there, and to ground. So you'd have ground on both sides of it. So I don't think that'll get you very far. Okay, the other side of the secondary goes up here through this 0.0005 microfarad capacitor along here and up to the oscillator grid. So that makes sense. I'm still not sure how the switching works for the broadcast band, but I know it works. That goes to ground up there. Now that's presumably disconnected, or it'll go to ground anyway, so it must then go through the secondary of the shortwave coil and up here. But that is the only path to the oscillator grid for the broadcast band coil. All I can do is check through that the grid actually does get as far as this capacitor, that the other side of this cap does actually get as far as the secondary of this coil. And I guess I can check this cap and perhaps this one, see what they measure. Now, according to the schematic, on shortwave, the other side of this coil, the side that's not connected to the oscillator grid, should go to ground when we're switched to shortwave. Now, switching it to medium wave, it looks as if it's running through a coil to ground, which is always possible the way it's set up. But yes, it does connect to ground once you put it on shortwave and not directly on medium wave. So that kind of indicates what I think's happening with this schematic. Now, there's a couple of capacitors here to check. There's this one from the primary of the hot side of the oscillator coil to ground, and for that I'll need the other meter. Now I'm checking capacitance here, and I haven't taken this out of circuit. It does go to ground to the other side of the coil, but I may not be able to get a reading off it without taking it out of circuit. No, nothing. That's not going to make any sense. It is marked 0.004, and I presume that's microfarads. Okay, so I've lifted that leg. It was a bit of a struggle because, like everything in this radio, it's looped through the terminal and twisted back on itself. That's stuck under there somehow, but anyway, I'll just see what we're getting now. So there we go. It shows us 0.63 nanofarad. Now the schematic shows it as a 0.5 nanofarad or 0.0005 microfarad. It's marked 0.00025, so it's about double its value, its marked value. So there it says 0.00025 on the cap body, and it measures more than double that. So it is a mica cap, though. I wouldn't have expected a problem with it. I'll see if I've got a replacement for it, see if that makes any difference. I doubt it. I'm probably barking up the wrong tree as usual. Well, we are now getting some shortwave reception. It's still very weak though. It's fading in and out a lot. It is very early evening. It's only about 5 o'clock. and I'm only able to tune one station at the high frequency end of the band. I'm wondering if it could be a matter of alignment. Nevertheless, the oscillator is running, enough to pick up stations anyway. Now, I'm not sure how significant the amplitude of the oscillator output is, that it could be that my scope was pulling it down as well. In fact, I'm sure it was, I'm just not sure how much. So I'm looking again at the RF section. I don't know where to go from here. I don't have a valve tester. I am beginning to suspect the mixer oscillator valve, the 6J8, or the RF amp, the what's that, a 6K7. What I might do is put a signal into effectively the aerial, the 6K7 grid, and just see how far it gets through the circuit. So I've set the signal generator up for 12 megahertz. Now that's about the middle of the shortwave band, so I guess it should be appropriate. And I'm just going to loosely couple it to the grid lead of the 6K7. And I'll hook the scope up and just see what we find. So first I'll just see what we're getting, if we're getting any signal actually on the grid of the 6K7. I haven't got the set on yet, I'm just looking at it cold, so I'm not seeing a lot there. But I'll see if we are getting anything. I'll just turn that up. Yeah, well look, we are getting something. We're also getting some AC hum in that, but it's getting through. Maybe I'll be better off to inject the signal directly. I'll put the scope right on the grid. Sorry, I'll put the signal generator right on the grid. I think I probably should do that through a cap. Alright, so here we go. We've got a cap directly onto the grid. So now we've got 12 kilohertz going through to that. I probably want another cap to put the scope on. What have I got here? There's one. That'll do. Okay, so the radio's on and working. 12 kilohertz going in, and just looking at it, if I touch the scope to that, that is the signal going in. So looking at the plate, and that's on pin 3, pin 1, 2, 3. So attaching the scope to pin 3 just through the cap, that's what we're getting. That's doesn't look right to me. That's what we're getting. I suppose there's probably RF on that as well, but I'll disconnect the aerial, see if that makes a difference. No, it makes no difference at all. So that's what we're getting on the plate of the 6K7. Surely not. Maybe I'm doing something wrong, I don't know. Or maybe the 6K7 really is not very good. I'll see what voltage we've got, see what DC voltage we've got. So you probably can't see that, I'll put it up here. So we've got 256 volts on the plate. 257. So we've got plate voltage. I've been rummaging through my miserable stock of valves, and I certainly don't have a replacement in here. I'm just wondering if there might be one in a radio around here somewhere. No chance of finding anything up here. They're all miniature valves. Now I do have this decrepit old HMV in the store shed here. It is a future project, but it's pretty rough. Let's just see if it has anything to offer. That is a 6B8. That doesn't help us much. It'll be an IF valve, I guess. Just pop it back in. I will one day get around to restoring this whole thing, but yeah, not today. See what it uses. This does have an RF stage. Up here we've got a 6J8. That's our mixer oscillator. I was suspecting that as well too, so I'll take that out. And I don't know what this is. Probably nothing of any value. 6K7 GT. I guess that'll be the same as a... There we go. New little beauty. Of course, I've got no idea if it's any good or not. Interesting little can it was in. Alright, I'll put the can back in here. So I'll just gently remove the grid cap here. There's the 6K7. Now, I don't know if that lead will fit over the can. I'll try it. Ooh. Yeah, I think it'll reach down there. If this makes a difference, I will get my hands on a 6K7G. Trying to get the grid cap on down there is not particularly... There we go, that's on. Well, let's see if that makes any difference. Oh well, it's plugged in. Let's turn it on, and I'll try a dim bulb just in case. No, that's alright, there's no shorts in it, so I'll go to full power. Wait for it to warm up.
We often talk about opportunity as well, and you know, what a great opportunity.
So that's on medium wave still.
I worked really hard with myself in the mids, you know, the last couple of years really. And
now, let's see what we get on shortwave. I'll just go down to the shortwave band here. We'll start at the high frequency end because that's where we're most likely to pick something up. It is late afternoon. The sun hasn't quite set yet, so I don't know if we'll get much at all. But it's not far off. We'll see how we go. Oh. That's probably China. That's definitely China. That's a lot better than it was, that's for sure. I think we're on a winner here. Was that valve all along? It's picking up heaps of stations.
AI-generated models.
Ooh, English. It's fading a bit. It is only early though.
2018年，阿里影业相关负责人陈楠介绍说，这部影片深入探讨全国电视裁判谴责枪击事件。
辛苦的对无？查甫相似较多。
我真好继续要知查甫。
你经纪个20几年啊？
系啊系啊。
来
一半对吧？
按过咧，你看桃竹苗。
嘿。
Yeah, it's going quiet as we go up in frequency, but it's still trying to receive, so there's some noise as well. There was no noise at all before. No, there's not much there at all. Let's try the band spreads. First band spread. Ooh! First band spread. Let's try to tune stations. There's not much. Well, that's working. All right, let's try the next one. Now I'll try the next band spread, see if it's working too. Just noise so far. Ooh. Anything else? Yeah. Well, that's a pretty good result. I think I'll come back down here later on tonight and just see what we get, because that's pretty spectacular for this time of day. Well, it's about 10 o'clock at night now, so I'll fire it up and see what we get. I'm getting some English language stuff here.
No certification. There is a degree qualification. So if you have, for example, you have a master's degree in English Lit, then if you apply...
See what else we get. There's not much down the low end.
States do...
Lots of stations there.
Sevgili dinleyicilerimiz, toplumsal kentleşme, gençlerin kırsal alanlardan göç etmesine neden olmuştur. Bundan dolayı da ailelerdeki yaşlı bireylerin...
But they're all working, that's the main thing. Hope you can hear me over the rain there. I just thought I'd repeat that check of the output of the tube with the 6K7 GT in it that I got out of the old HMV. So this is the signal I'm putting into it. I'm using 10 megahertz because for some reason the scope doesn't like 12 today. It's a crusty old oscilloscope, probably needs recapping. But anyway, looking at the output, and I'm just touching the end of the cap to the plate here, and there we go. We've got about the same amplitude output as input, so there's not a lot of gain happening there, but it is putting out a pretty reasonable output, I guess, at 10 megahertz. I'll try putting this up to 12 megahertz as I did before, just to do like for like. Yeah, that's looking pretty. That is the scope. That's a problem with the scope rather than, I think, the output valve. Anyway, there's a definite visible difference in the output there, so I feel a bit better now. I thought I was just not doing things right before, but there you go. Well, one remaining thing to do is to connect up the Magic Eye tube, and I don't know if the one I've got will work anyway, but it needs to be connected. And so I've been going through the chassis trying to identify which wire is which. So I think I've got them all identified now. I'll put them onto the valve holder and hopefully we'll get something out of it. So I put the Magic Eye tube in position with its original cord attached, just to get I suppose the appropriate length for the wires to go onto it, and we want to allow a little bit of length here, I guess. I think about that will be fine. I don't want to lose the labels off them. So I've trimmed them all to length, and before I forget, I better put the cap over these, otherwise I know I'm going to leave it off. I've done silly things before, and I'll do them again, but this won't be one of them this time. So there we go. Oh, I didn't strip that. That's right, I wanted to relabel it. Alright. I've also done a list of wire colours and pin numbers, just so I don't make any mistakes if the labels come off or something. I'll just strip this one. I originally used, or intended to use, this cloth covered wire for all of them, but it's thicker than the original and it wouldn't go through the hole in the chassis. It was too tight, so I've substituted a couple of plastic wires for the heaters, and kept these for the higher voltage ones because I don't know about the voltage rating of this plastic wire. It should be okay with 6.3 volts, but I wouldn't trust it with plate voltage. I think it's automotive wire, which is not great usually, but normally okay for carrying a reasonable amperage. Anyway, there we go. So now it's pretty much a case of just soldering them on and not getting the pin numbers mixed up. Now this thing, six-pin valve with two fat pins here and here. They go on these two, which is, I think, so they're pins 1 and 6. They're going to be the heaters. So that should have originally been a blue wire on there. Well, that's a blue wire there, and that would have been black once upon a time. You can see why I had to change the wire here. It's pretty bad. Just going over the pins with a bit of solder wick to make sure all the holes are open. Yeah, that looks pretty good. That'll do. Okay, I thought I'd start by putting the heater ground on pin 1. That'll serve as a good reference so I don't make any mistakes counting. And I've also slipped a bit of heat shrink over there to keep the wires together, and I'll put some sheathing on them. I don't have anything exactly matching what was on it, but I've got something that'll do the trick. There we go, that's pretty solid in there. And if I feed all the wires in from the same direction, I shouldn't have any major dramas. And a bit of paper under here just to avoid dropping bits of solder down the guts. Alright, pin 6. In you go. There we go, all the way in. And the last one is the grid, goes on pin 3. So and I'll just clip that off. Alright, now I should be able to just bend these all back. So I plan to use some of this fabric, it's actually nylon or something covering, and I'll just cut a piece long enough so it will hopefully poke through the hole in the chassis as well, if I'm lucky. And getting this stuff on is a bit of a trick. It wants to close over itself, which is what it's supposed to do. But it would help if it closed over after all the wires were inside it, not before. Now I'll have to trim the end off here, I guess. Possibly about there. And try and get that heat shrink over the top of it. That'll be my next trick. Alright, now I'll get a bit of heat onto that. Now, it just remains to clip this on. I'm not going to yet because I want to put some kind of insulation around the inside here. It shouldn't contact any of the pins, but gee, I'm pretty sure it had some sort of insulation in there to start with, so I want to make sure that that's okay first. Well, here we go. I'm going to put it on dim bulb first, just to make sure I haven't done anything silly. That doesn't seem to be showing any problems. Do we have a heater in the magic eye? Can't see one. Not seeing any heaters yet though, so that's not surprising. See if we've got any reception. Yeah, we have. We don't get much reception on dim bulb, but it'll work. Okay, so going on to full power. I'll just turn that down. Now I'm still not seeing a heater in there, which worries me a little.
They can gain some small solace knowing that the father died.
There's absolutely nothing happening.
Instinctive act of bravery in the face of a terrible, terrible accident. He gave his own life to try and save his children.
Computer systems are still coming back online.
I'm not seeing a heater at all in that. I'm wondering if it might be open circuit. So this is the heater, the two fat pins. No, it's not open circuit. we have continuity. Okay, so it's not that. So turning this on to DC volts, and I'm just turning the set on. We'll see if we got voltage at the pins of the socket, and we don't. We don't have any. That's DC volts, Don, you idiot. AC volts. Yep. Okay, so the radio's running, and I just thought I'd check what voltages we're getting here. And this is looking at the target, and we have 258 volts on the target. Down here, looking at the plate, and we have 60 volts. I'm not sure what volts we need on this valve for it to work. I'll look up the specs and see what it needs, but I suspect that that plate voltage is a bit low. Seeing that plate voltage is so low, I just changed this 1 meg resistor between the target and the plate. It was measuring a bit high, it was about 1.4 meg. I don't know if that'll make any difference, but I'll give it a try, see if that gives us anything. Well, unfortunately it's made zero difference. There's nothing there. I've tried turning the lights off. I'm not getting the faintest glow out of it at all. I'm not out of options yet though. I did pinch this 6U5 out of that old HMV I've got in the shed. It looks pretty crusty, but you never know, it might have some life in it. Well, there we go. This one does have some life in it. It's not overly bright, but it's definitely there. I'll need to turn it around a bit because the indicator section is down there, but it is working. It's opening and closing as you tune stations, so that's probably as good as I'm going to get without buying another 6U5 really. So we're pretty much there. One remaining thing is to sort out the dial lights, and the dial light in it, there was only one, has this 6 volt, I think it's a car lamp in it. Now I'm not sure if that's correct. I don't know exactly what type was in it, but I haven't been able to get anything similar to that. This is not connected, by the way. You'll remember that this is not the original transformer. The original transformer had a tapping on the filament winding, and the dial lamp was attached to that. So this is disconnected. Now Steve in New Zealand has sent me this pair of correct dial lamp holders, so that's handy, and they clearly take the same kind of globe. I had a look around and I wasn't able to buy a 6 volt one the other day, but I'll try a motorcycle shop. They might have 6 volt lights. I don't know. I'll look around. I might be able to get them online. Steve has also sent me this beautiful set of knobs, two with two of the large ones with the sailing ship logo on them, and so I'll be putting them on while I'm waiting for dial lamps and such. This does need a good clean up. I've done a little bit of cleaning as I go, but it really does need a thorough clean up. The chassis is still pretty grotty, so I'll get onto that and fit the dial glass, and pretty soon I should have lamps for it. Then we can start work on the cabinet. I will lace up these this wiring to the speaker, but I want to see how it sits in the cabinet first, just to make sure it sits okay. So I've taken the frame off it, so I can get at it at least, and a lot of this looks pretty rusty and crusty, so we'll start with this piece over the dial here. Need to do some rust treatment on that for sure. This is rusty as well. This can come off. So I'll start stripping what I can off the chassis. I'm not going to take it right back, but it does need a good clean up. Well, if you want to see how it looks all cleaned up, you're going to have to watch the next video, because this is the end of this one. I'm not going to go overboard with the clean up. I just want to keep it original and as clean and tidy looking as I can without altering it too much. But next time we'll do the cabinet. I need to do an alignment, I need to sort out the dial lights, and that's about it. We'll put it back together, and I think it's going to be a really nice radio. Anyway, I hope you've enjoyed this. Thanks for watching, and catch you next time. Bye for now.